This is our last type of calculation in the titration set, pH after the equivalence. And this is really different. So now you're doing a reaction and you've added more strong base than you need. So you have reacted all of your sample and you've added a little bit more of the titrant. All right, so the same sample, 25 mils of a 0.5 molar weak acid, titrated with 0.8 molar sodium hydroxide, and we have added 16 mils. Well, if you've watched all the videos, let's say this, you have already determined that the equivalence point happened at 15.625. So we are now past the equivalence point with 16 mils. So if I set up a buffer type calculation, there's going to be excess strong base. So we have the 0.5 molar weak acid and we have 25 mils of it, which becomes 0.025 liters. 0 of the conjugate base. And if I find moles, I have the 0.0125 moles and 0 moles of the conjugate base. If I react the strong base, so my strong base is 0.80 times the liters of 0.016. If you convert that to liters, you're going to get 0.0128. So I'm going to subtract that from my weak acid. And you see that this number is bigger. So I can't really even do that subtraction correctly. I can't make that much conjugate because I don't have that much weak acid. I can convert all of the weak acid to conjugate base, but you're going to find that that doesn't really even matter. When I do this subtraction, I get a negative value. That should be a big clue that something is different here. And this is what I have over here, but this part doesn't even matter. It's this part we're worried about. All right, so really, we just want to know what the extra is. So I'm going to treat this as absolute value. So plus 0.0003 is my excess sodium hydroxide. So I need to find the concentration of that, and then I can find the POH and pH. All right, so I'm going to determine the concentration and calculate the POH and the pH. So I need the total volume. So the sample plus the amount of base added is 41 mils. So I'm going to take my moles of sodium hydroxide and divide by my total liters and get my concentration of sodium hydroxide. So the POH is the negative log of that hydroxide concentration of 0.007317. And the POH is equal to 2.136. And if I subtract from 14, I get 11.86.